Hey, everybody, welcome back to episode 6 of the Rule Your Pool podcast. I'm your host, Eric Knight, and with me, as usual, is my co-host, Jared Morgan. Jared, thanks for being here.
Howdy. If you're watching, great. If you're not watching, I'm just supporting a new hat we have here. Everybody can take a look.
Yeah, the Orenda Academy exclusive hat. I have mine. Mine's flat build. I'm not wearing it because, well, I look silly when I wear a flat build hat. But they are popular, and you can get your hat by passing Orenda Academy 4 pillars. We will personally give you a hat. So thanks for that shameless plug.
I'd happy to give you a curve build hat too.
Flat build is probably better because we have an internal bet going on, and I think more people will like flat.
Whoop, what's the topic today, buddy?
Today's topic is understanding calcium hardness. We have been covering the LSI. The first few episodes were about alkalinity and pH. And as you know, that's 2 of the 6 LSI factors. The last episode, we talked about water temperature. So today, we are covering calcium hardness. And of course, the next 2 episodes will finish out the 6 factors of the LSI. So as a recap, the LSI, the Langmuir Saturation Index, it is the objective way that we measure water balance. And there's 6 factors. So we're going to cover it. So we just have a few takeaways, 3 of them today. Calcium hardness is the most stable of the 6 LSI factors, and therefore it should be the foundation for your strategy. Water temperature, we said last time, that's the moving baseline, but calcium hardness really doesn't move unless you move it. The second takeaway is calcium, surprisingly, is not the leading driver of carbonate scale. Everyone thinks it is. Oh, I have too much calcium, therefore I have scale. That's actually not true. It's just one of the contributing factors, and it's not even one of the major ones. And we'll get into that. And the final takeaway is we're going to discuss what can raise calcium hardness levels, beyond just adding it with calcium chloride. And the few things, there's only 2 of them that we can think of that actually lower calcium hardness. So, Jared, you ready to get going?
Ready.
All right. Without further ado, episode 6 of the Rule Your Pool podcast, Understanding Calcium Hardness. Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go. Okay, so of the 6 factors of the LSI, calcium hardness is one that people don't measure very often, but it's probably your best friend. And in the last episode, we talked about water temperature because water temperature is certainly the most ignored. I would say it's the most neglected because people just don't think about it. But you can't really control temperature unless you crank up your heat. And you just have to adapt because it moves. Calcium hardness really doesn't move unless you move it. Regardless of temperature, your calcium hardness is going to stay remarkably consistent throughout the course of the year. And that's a really good thing. So if we set it at, say, 300 parts per million, there's a good chance it's going to be about 300 parts per million next month, depending on the type of chlorine you use and depending on how you treat that pool. For instance, do you add acid properly? We'll discuss that in the third takeaway of what can actually affect your calcium hardness levels. But the point I'm trying to drive at is it's remarkably consistent. Now, Jared, you've got a pool. Where do you keep your calcium hardness level?
My calcium hardness level is roughly 500 to 550 parts.
Whoa, time out, bud. Let's pump the brakes. 500 to 550. What does the textbook say it should be?
2 to 400.
Okay, so you are in deliberate violation of textbook range chemistry. Now, you heard it here first. If you didn't already know that, we don't always abide by textbook range chemistry because we at Orenda, we preach a philosophy that is LSI first, range chemistry second. And this is especially true for calcium hardness. Depending on where you are, you may need a lot more than 400 parts per million. I guess I shouldn't say a lot more. You may need more calcium hardness than 400 parts per million, especially in colder climates.
I would say you need more. I think it's something that people get scared of or paranoid of. So they try to keep it as low as they can in fear of scale. But it's not that you may need more. It's just we can manage our water with more. A lot easier in our opinion, but it's definitely something not you don't want to be scared of your calcium level.
Oh, absolutely. It's, as Harold likes to say, it's calcium is treated like it's a 4-letter word. In reality, it's your best friend because it doesn't move, and it is also not the leading driver of scale, which is our second point here. But what I want to say is, because it's so remarkably consistent, that is the foundation to build your chemistry strategy around. So if you have this rock solid foundation, an analogy is kind of like if you were going to build a house, would you want to put it on a marshland, like a muddy swamp, or do you want to build a solid foundation? And calcium hardness is that rock solid foundation because you know if all other factors change, you at least have that many parts per million of calcium hardness, which is going to help you stay within LSI balance regardless of your other factors.
Now, I can hear some naysayers thinking in their head right now, well, what if I live in Southern California in the desert or in Phoenix and I get roughly 6 feet of evaporation a year? That's going to artificially increase my calcium and TDS level.
Mm-hmm. Continue your thought. I like where you're going.
They're saying they can't get a pool at, say, 400 or 500 parts calcium because that's just going to skyrocket over the course of a normal swim season.
Right. Well, and I would actually add on to that. You're absolutely correct. I would actually add on to that there's a common thought in places like Phoenix. We've been there a lot, you and I, where everyone says, oh, we have really hard water here. And you would be right if you were getting well water out of the ground in Phoenix. But municipally treated water, I've been there. I've tested a lot of tap water. I haven't seen anything over 100 yet. Now, granted, I'm sure it exists. Phoenix is a huge valley, but I haven't seen anything over 100 parts per million, which means that the municipal treatment plants are softening the water because I bet faucets and all sorts of other things were getting scale problems.
You're absolutely right. And a funny, just quick test that I like to tell companies when I go do training or something, I'll ask them if they have soft or hard water. And generally speaking, obviously a few know, but some are like, oh yeah, it's hard. Well, there's a quick test you can do. If you go wash your hands and it feels like you can never get the soap off your hands, you have soft water.
Yeah. Yeah. Or you could just take your test kit to your sink where you wash your hands.
Who uses test kits, dude? Nobody uses those things.
Well, hey, you know what? We preach on startup especially, but for every pool, you have to know what the tap water chemistry is.
But there is a preconceived notion of what your water makeup calcium level is. And in reality, it's way different than what you think it is.
Yeah. So if you listening, go on the Orenda blog or just go into the Orenda app, which we mention this every episode, but it's just called Orenda, Orenda. It's free in the App Store and Google Play. If you go in there and you go to articles and type in evaporation, there's an article in there called Evaporation and Accumulation. And it talks about exactly what Jared just brought up. It talks about the fact that hotter climates lose a lot more water. And when water evaporates, it leaves everything behind. All of its salts, all of its minerals, total dissolved solids, which includes, of course, calcium hardness. And so what happens is you lose this water, then you replenish from the tap, or from the hose, whatever you want to call it. And that will actually accumulate more calcium hardness because you have some in your tap too. Even if it's a low number, the fact that your minerals just accumulate over time, much like cyanuric acid does, you get more and more over time.
There are some places that have 5-10 parts calcium out of the tap.
Oh,
which
yeah.
is a completely opposite problem, but yeah.
Well, that's true. But in high evaporation areas, you just have to kind of be aware that these numbers can accumulate over time. So yeah, you shouldn't personally raise it in Phoenix to something like 500. If your tap water is, let's say 80, you should probably raise it to more like 250 to 300 because over the course of that season, it'll probably get to almost 500 by the end of the summer. And
that's exactly where the point is. The point is if you are in hotter weather climate, you need to run a more conservative level of calcium hardness. Yeah. So let's talk about how we actually test that. There's electronic test kits that are pretty accurate, although there's questions in the industry of how accurate which test is which. We're not getting into that. That's not our business. Just make sure whatever test kit you're using is calibrated and it's treated well, and you don't leave it out in the sun all day. But the most common one that we think of is a reagent test kit, a titration with drop kits, right? And you put all these drops in, and I use one of those kits
around here, I also use digital. I also use strips here and there. But basically, I use whatever the customer has, because when I fly around the country, I guess pre-COVID, I can't fly with my test kit. Liquids are not allowed on flights. So even if they're all in small little bottles. So it's just a pain. So I always use whoever's test kit is there. So it's always something different. But how many times, Jared, have you tried testing calcium hardness and then you get like those little pink flurries or flakes floating around in that sample?
It takes a lot longer to get it to turn purple or blue, I guess I should say.
Yeah, it's supposed to turn blue. Yeah.
Yeah, but it turns purple, and it just seems like it sits on purple, and no matter how many drops I add, it's just always floating balls into the cylinder.
Well, I was just on the phone with Wayne from Taylor. Taylor's the leading manufacturer of those type of test kits. And he was saying that those little pink dots are magnesium hydroxide. And part of the issue of why the color won't change, normally you can still get it to flip, but you'll have these little floating dots. But if you have enough copper or iron in that water too, the color of the sample won't actually change. And so what he advised is, he says, use, I think, the number 12, the titration one that you count the number of drops, put 5 of them up front because they have a sequestrant in it. And that'll take the iron and copper out of the equation, and then go through the test and just add that 5 to the total number. And that way it kind of gets ahead of it and you'll be able to do it. There are other test kits and methods to testing, but what we need for the LSI is not total hardness. We need calcium hardness. And that's what that titration test does. It takes the magnesium out of the equation, because if you add magnesium and calcium together, you'll get total hardness. We just want calcium hardness. So that's what that's all about. Now, soft water versus hard water is, there's a lot of different ways you could soften water. There's magnetic systems that can do it, because at the end of the day, calcium is technically an alkali earth metal, believe it or not. Did you know that, Jared?
Not until we started selling our scale and metal control product. That's the reason why we call it a scale and metal control product, but really we should just call it a metal control product.
Yeah. Well, yeah, it is kind of confusing. I didn't learn it until I was at, I think, the NPC conference and said, oh yeah, calcium's an alkali earth metal. Really? And then you think about it, magnesium's a metal, but we also call these things minerals. So if we refer to them as minerals, that's why. We're referring to...
Minerals is a lot more appealing to the ears, trust me.
Yeah, because when I think metals, I think iron, and I think copper, I think silver, and those kind of things. But calcium technically is a type of metal. And so by getting the calcium down, your water takes on new properties. And we don't need to go all the way into them. That's much more of a drinking water conversation. And like you said, soft water has a lot harder time getting soap off of your hands. Hard water is very easy to get soap off your hands, but it'll also leave things like white dry marks on your dishes in your dishwasher. You've probably seen that too. Mm-hmm. Now, Jared, why do you think that happens in hard water dishwashers?
Probably because there's more calcium left behind after the dish is dry.
It is. There's some evaporation, but it's really because of heat. And that is bringing me into our second takeaway. Of course, the first takeaway we just covered was that calcium is your friend. It is the most stable of the LSI factors. It doesn't move much unless you move it. The second takeaway here is that calcium hardness itself is not the leading driver of scale formation. I'm going to repeat that. Calcium hardness is not the leading driver of scale formation. And it's easy to get confused about this because when you look at scale, Jared, what does it look like?
It's white calcium.
Yeah, it's calcium. Common sense would say, oh, I clearly have too much calcium hardness because I'm looking at calcium. Well, you're actually looking at calcium carbonate. That calcium carbonate is determined by the LSI, not just calcium hardness. And calcium hardness is just one of 6 factors that precipitated that. And come to find out, it's like the 4th most important one out of the 6. The number 1 driver of scale is the pH. You get a pH over 8.2. You could still have scale at like 7.8, depending on other factors. But if you get it over 8.2, you have a very high probability of scaling. Number 1 factor is pH. The number 2 factor is water temperature. We touched on that in the last episode, because pH will largely precipitate calcium, but temperature is what determines where that calcium precipitates. Remember, we talked about salt cells and heat exchangers and sunny tile lines? That's a temperature thing. The next biggest factor, you could argue because they're very similar, it's either alkalinity or it's calcium hardness. But neither of them are even remotely close to pH or temperature in terms of precipitating calcium scale. And that's a big misnomer.
Which is a big point here because there's a lot of commercial pools that use CalHypo tabs as their primary sanitizer that have calcium levels up near 1,000.
Yeah.
But they don't have scale.
Right, because they manage the LSI or a similar index like the Reisner. A lot of our commercial customers use CalHypo every day. And CalHypo, I hope I have the number right, it's about 4 parts per million of added calcium hardness for every pound of CalHypo in 10,000 gallons. That's a mouthful, but basically it will slowly rise your calcium hardness. And of course, over time, it rises significantly, but not over the course of a week or two. You don't really notice it. But if you are using CalHypo as your primary chlorine, you know it's going to go up.
Unless you're abusing the use of CalHypo because you have to shock your pool too often or overshock your pool.
Right. If you're struggling to have breakpoint chlorination because you have too many nitrogen compounds and you have to keep shocking, well, yeah, your calcium's going to rise pretty quickly. So just be aware of that. But we're going to touch on other things that rise, or I should say raise. We're going to touch on other things that raise calcium hardness in just a minute. The point here is high calcium hardness itself is actually to your advantage. Use the Orenda app LSI calculator and you'll see what I mean. You can have high levels of calcium and not have scale. The real question is, where do you keep your alkalinity? And how do you contain your pH? We covered a few episodes. You don't want to control pH because it's going to rise naturally through physics. So where do you contain it? Our thought, and we'll have Jared touch on what he does in his pool, our thought is have a little bit more calcium hardness and have a little bit lower alkalinity. The key here, if you're going to lower the alkalinity, is you have to measure your acid because alkalinity is what protects the downside. If you drop out your pH too much, alkalinity protects. But if you're measuring your acid and adding it correctly, you don't need nearly as much as the textbook might say. Would you agree with that, Jared?
Absolutely. And I know, like I said, we've touched on my pool and where we keep it over the last couple of episodes. So if you've listened to those, this is obviously nothing new. But yeah, I maintain my alkalinity around 60 parts per million. That way I have a higher calcium hardness, so they offset. And I'd rather have a higher calcium hardness because like we're talking about here in this episode, it's way more stable and predictable and manageable versus bouncing the pH and alkalinity back and forth with one another.
Right. Well, how about cost effectiveness? Especially if you're a pool service pro listening to this, you service multiple pools every week. Bicarb is not free. You could set your calcium hardness to a good position. And if you don't know what that is, contact us. You can contact us directly through the Orenda app or on social media. We get questions all the time. The answer of where your optimal calcium hardness level should be, if you're going to take one sentence out of this, I guess this would be it for the whole episode. The ideal calcium hardness level for your pool is whatever allows you to maintain LSI balance year round. That's it. And it's going to be very different in Wisconsin than it is in Tucson, Arizona, because the climate is different. The temperature parameters are different. Their winter in Wisconsin is going to be freezing that pool. Tucson doesn't have that. And so there's a big difference in what that pool is going to need LSI-wise in the summer and the winter. It also has to do with the amount of sunlight. It has to do with how much evaporation you're going to have. If you need help with it, just contact Orenda. We can help you out. So all that is to say, don't freak out about slightly higher levels of calcium hardness because you can actually replace your LSI value that you would have had with 80 to 120 alkalinity with a higher level of calcium hardness, and you can have a lower alkalinity. You'll still have, play with it on the calculator. You'll see it in real time. You can still have LSI balance. And the nice thing about having the higher calcium is it doesn't move. That's the key here.
Well, the other thing that adding bicarb to your pool constantly and playing that game is, I noticed it the first year roughly when we built our pool. I was adding a lot of bicarb. My salinity level got pretty high.
I bet.
So, sodium part of that bicarb definitely has a factor here.
Oh, for sure. It absolutely does. So I guess trying to wrap that up is, don't be afraid of high levels of calcium, because it's going to lead to problems. And I'm going to give you one real world example, and a very, very costly example. And it affects pretty much everywhere that pools freeze. Jared, you know exactly what I'm about to say. But for the audience listening, several years ago, I went into the Northeast. It was in Pennsylvania. And then the next day was in New Jersey. And the next day was in Albany, New York. And the first day I was told, oh, go to this customer. They have a recurring scale problem. Scale. Okay, scale. No problem. And I go to meet this customer and they start showing me pictures, telling me the symptoms. And I'm looking at it and I'm thinking, that doesn't look like scale. You have all your water chemistry records. I plug in the water chemistry records and nothing is adding up here. I'm thinking, we dropped the temperature. You're not getting a high LSI. You're getting a very low LSI. And what the customer said, and by the way, if you're listening to this, call me if I'm wrong on this, but I'm pretty sure it's a direct quote. You've got to be effing kidding me. Because for so many years, what he had been doing was lowering the calcium hardness or keeping it to a low enough level going into the wintertime so that they didn't have scale when they opened up in the spring, because everybody thought it was scale. Well, one simple look at the Orenda calculator said, that's not possible. That's not scale. And then I started asking questions like, was it on light fixtures? Was it on the face of tile? Or was it between the tile? Only on the grout. Come to find out, it was not on any plastic light fittings or anything like that. It was only coming out of the plaster. In fact, it wasn't even on the pebbles in the plaster. It was between it in the cement. I said, these things are growing. Come to find out, they're crystals. They are a type of calcium carbonate, but they're just a much denser type. And they are called calcite crystals. They are not scale. They're formed by low LSI violation. And it was a consequence of thinking that too much calcium hardness was a problem. It was not a problem. They didn't have nearly enough to get through the winter. So if you're going to feed your pool going into the wintertime, feed it calcium. Feed it calcium. And that right there, being able to balance your LSI at the lowest degree that you're going to have, say it's 40 degrees or 32 degrees in their case. If you have enough calcium hardness, it will stay in solution in cold water, which brings me to a little bit of a tangent before we get to our last point here. Most things dissolve better in hot water, right? They'll stay in solution better. If you heat up, you can dissolve more sugar or whatever you have. Calcium's the opposite. The colder the water, the better calcium stays in solution, which is why cold water makes water more aggressive, because it's hungrier. It wants more calcium. So the colder your water, you can load it up with calcium hardness. And the hotter the water, of course, you precipitate, like we discussed last episode. So Jared, any comments here before we get to the last takeaway?
No, I know I've run into a couple of situations where houses have water softening systems for their home. And a lot of times we'll fill a pool up, or, we'll maintain a pool and not realize, or really it's just ask the question, is this spigot I'm filling this pool with tied to your water softening system? Because if it is, you need to take that into account when you're maintaining that pool, because you're not going to be adding calcium through the tap water, which means you're going to have to artificially add it during your maintenance.
Or your startup.
That for sure. No question in there. But just normal routine maintenance, your calcium level is going to drift down, especially if you're using a liquid chlorine as your sanitizer. So you're going to have to artificially account for that when you're doing your weekly maintenance.
And Jared, that brings us to our final takeaway here. There are many things that can raise calcium hardness, and we'll cover them, but there's only two ways, and I want to start with those. There's two ways to lower calcium hardness. The first is obviously to drain and dilute. Same thing for reducing CYA, same thing for reducing salt or TDS. Drain some water, dilute it with fresh water. This, of course, for calcium depends on the calcium hardness of your tap. If you have 1,000 calcium hardness out of your tap, draining the pool and replacing it with that is probably not really going to do you much good.
That's when you're going to run it through an RO system of some sort.
Correct. That is a reverse osmosis will get rid of calcium hardness and TDS and all sorts of other stuff. So draining, I guess there's 3 ways then, not 2, because I didn't think about RO. Good point. So diluting is the main one. RO is the next one, especially if you're in like a drought-stricken area that you're not allowed to drain. Reverse osmosis is a good alternative.
There are companies that have a trailer that you run the water through that will purify that water. There is there is a waste to that, and I think it's gotten better over the years. But last time I heard, it was 15%.
Yeah, but I mean, even if you only RO half your water, you're going to cut down your calcium hardness in half, and your total dissolved solids, and your CYA, and all that. So just keep that in mind. That is an alternative. There is another way that you can lower calcium hardness without lowering cyanuric acid or TDS. And that is by throwing soda ash into your pool.
I was going to say, I think I know where you're going with this. And
it's a terrible idea. If you're listening and you don't want this science experiment, just don't do this. But
sure, it's been done, but boy,
if you really want to get rid of calcium, you can force an LSI violation really rapidly by throwing soda ash into the pool. And if you've ever put soda ash too fast, it'll cloud up and you're like, no. And it just takes over your pool. What you're watching is a real-time LSI violation. And it's converting bicarbonate alkalinity to carbonate alkalinity. It's binding with calcium. It's turning white and it's falling out as dust. And you can vacuum that dust out of your pool and lower your calcium hardness.
Specifically, you can vacuum that calcium carbonate straight out of the pool.
Oh, yeah, you absolutely can. You can vacuum it out. Now, we don't recommend this method unless you're up for a 4-day excursion in seeing how fast your pool can clear and fall. And you'd have to shut off circulation because your filter will capture it. It's a mess. But technically, that is a way to lower your calcium hardness.
Technically, yes. Let's steer away that one. But yes, you can.
Yeah. Hey, you know what? We're here to be honest brokers of true information. We don't want to leave it out because let's be honest, it is the coolest of the ways. It's also just the biggest pain of all of them. So just drain and dilute if you need to lower it. So let's talk about what raises it, and then let's wrap this episode up. So obviously, calcium chloride. That's the product that we use. It comes in 3 different forms. Usually, you'll find 2 very easily. You'll see either 77% flake, which is what almost everybody uses. And you can also see 94% prill or granular. There's also calcium chloride powder. It's a lot more expensive. It's harder to come by. Not every distribution place sells it. Not every retail store sells it. But calcium chloride, CaCl, or CaCl2 actually, when you add that to water, the chloride will separate out and you get calcium hardness in your pool. It gives off an exothermic reaction, which means it gets really piping hot. So you have to be careful when you mix this. This is why for the Orenda startup, we have a special barrel that is rated for 250 degrees Fahrenheit, much hotter than the boiling point. I mean, we took, didn't you have like an infrared thermometer and it got up to like 190 degrees when we put all that calcium in the barrel?
I don't remember what the temperature got up to, but it was a 30-gallon barrel and we put over 100 pounds of calcium chloride in there.
It's stupid. Don't ever do that. We did it as an experiment. It was a lot. We were
just
testing.
To see how hot.
Yeah, we were getting our Bill Nye on, and we were just doing our best to see how much that barrel could actually take. And it handled it, but it got hot. Like you could have burned your hand touching the outside of the barrel. It was so hot. So be very careful when you mix it. You want, dilution is the solution. The more you can dilute it, the less risk you're going to have. And another way to get that calcium into solution is to chelate it. This is where SC1000, our product SC1000, comes in. If you put just a little bit, say you have a 5-gallon bucket and you're dissolving 15 pounds of calcium chloride, what would you say? A tablespoon of SC1000 should be plenty for that amount?
Yeah, not a lot.
Not a lot. Teaspoon, tablespoon. That will help substantially to dissolve that. But here's what you have to be aware of. SC1000 has a pretty high pH. So you have to have a little bit of acid to offset that. For every quart of SC1000, it takes 12 ounces of muriatic acid just to neutralize its pH. So be aware of that. If you didn't have SC1000, just putting a teaspoon of muriatic acid in that bucket will also accelerate it going into solution. So, of course, you can add it, number one, by adding calcium chloride. Number two, cal hypo. We discussed this a little bit earlier. I believe it's about 4 parts per million per pound of cal hypo per 10,000 gallons. So it's not a huge way to raise it, but if you shock enough, or if you're just using cal hypo year round, your calcium hardness will go up. Then there's the bad ways to get it up. And that's usually the abuse of acid, which causes etching of a plaster surface, and it steals calcium from your surface, from your cement, from your plaster, whatever you want to call it. When your calcium, quote unquote, and for those of you not watching, I'm using air quotes, drifts up, that's a lot of cement. And for a typical 20,000 gallon pool, we've heard 2 different figures. I'm not sure where it lands. But if your pool on a startup, let's say your tap water is 80 and it drifts up 100 parts per million on its own to 180, on a typical 20,000 gallon pool, that's about 33 pounds of cement. I've also heard 16. So we're kind of like one is half of the other. I'm not sure exactly what it is, but either way, that's a lot of pounds of cement that water dissolved to try to get its calcium hardness up. So you can either feed the water the calcium it needs with calcium chloride, or it will feed on its own to balance the LSI.
I did went and looked at 2 jobs for a pool builder here in North Texas. Both of these houses were next door to each other. So the exact same water. And one of them was, they did a hot start on, or a 0 alk start on it.
Oh, yeah.
And the tap water was, 120. But on the first pool I went to, the tap water, or the pool water, measured about 250 calcium hardness. No hot start on that pool. I went to the pool next door. They did a hot start on it, and it was over 500.
Oh my gosh. Well, where do you think it came from? If you didn't put it in, where did it come from?
The plaster was absolutely torched. It was rough as can be. The spa was a different color than the pool, a lot darker in the spa than it was in the pool. And you can see, just areas in front of return lines where you could tell the acid was blowing the water on the surface, and it was just eating it up.
Yeah. Well, that's pretty much it. I mean, the summary of this entire takeaway is if you didn't put the calcium in, either through calcium chloride or cal hypo, it came from somewhere. Now, that brings us to the last place, and that would be the tap. You need to know what your tap water chemistry is for every parameter, but especially calcium hardness. pH can fluctuate in tap water pretty rapidly. Calcium hardness does not. They have to fundamentally change something in the municipal treatment plant, but calcium hardness is pretty, pretty stable, I should say. I mean, you have to actually really change how you treat the water, whereas pH can fluctuate depending on how far the pipe goes.
Well, it's because most cities get their water from a specific source that does not fluctuate very much unless there's a drought or some unforeseen circumstance going on they're having to manage. But for the most part, it's the same water. They're treating it the same way.
Well, I'd go even further than that. I've been in a neighborhood in Florida where this one house we were at, because the pool service company did everything on that street, this one house had 50 calcium out of the tap. The one across the street had 90. I mean, they were literally across the street, not even 100 yards away, and completely different calcium taps. Come to find out, they're coming from 2 different treatment plants. Mm-hmm. So you have to kind of look into that. Don't ever assume that you know what the calcium hardness is. So anyway, I want to wrap this up. Do you have any final comments here, Jared, before I wrap up these 3 takeaways?
No, my final comment is, we didn't really touch on how often calcium hardness should be tested, but I think in our opinion, at least every 3 weeks 3 to 4 weeks is a good baseline, because since it doesn't fluctuate much, that's a good thing to check every 3 to 4 weeks.
Yeah, I like it monthly. That's especially if you set it to where it is and you're managing the LSI every week and you're measuring acid, you're not column pouring it, you're not overdoing it, then your calcium is going to be remarkably consistent. It's going to go at the exact same evaporation rate. It's going to go at the exact same rate of your chlorine. So it's a very reliable source. So in closing, the 3 takeaways. Number 1, of the LSI factors, calcium hardness is the most stable. Therefore, it should be the foundation of your strategy. Pick a calcium hardness at an optimal level for your pool. And that optimal level is whatever allows you to maintain LSI balance year round for that pool. Colder climates, you're going to need more. You're going to need 400 to 500 or so. Maybe in the wintertime, go over 500. Trust me, it'll dilute with rain. Because dilution, rain is a great way to lower the level over time because Rain has no minerals in it. Evaporated water coming back in, rain and snow over the winter, they lower the water level a foot. That will definitely lower the level, like we said. Dilution lowers the level. But you need that calcium in the off season. It is your best friend. Number 2, the takeaway, it is not the leading driver of carbonate scale. pH is. And what drives the location is going to be temperature. Then you have calcium and alkalinity, roughly the same magnitude of what is going to be a contributor to scale. So don't just expect that you have super high or too high calcium hardness because you're seeing scale. You may not. You could scale up a pool at 100 calcium, which is, we would argue, very, very low if your other parameters are out of whack. And finally, of the things that can raise calcium hardness, we hope that what's happening is either you're putting it in or it's accumulating over time through natural evaporation, not from etching your surface and stealing calcium. And to lower it, of course, you either dilute it or you filter it out. So, Jared, any final comments? I feel like we covered calcium hardness pretty in depth today.
I was going to say, we touched on this subject about as interestingly as you possibly can.
Well, we'll have 2 more to finish out the LSI, and then we'll get into a new subject matter. So, thank you again for listening. This has been the Rule Your Pool podcast. If you have any topics that you want us to discuss, just contact us on social media. Orenda Technologies, we're easy to find. We're all over the internet. You can comment on the video below, or in the comments below, I should say. I'm your host, Eric Knight. This has been my co-host, Jared Morgan. Thank you again for all your time. This has been episode 6 of Rule Your Pool, Understanding Calcium Hardness. Take care, everyone.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.